Okay, what you're going to do right now is something similar to the club soda BTB lab, but instead of having club soda, we're going to take ethanol and alcohol and we are going to set it on fire. We're not going to do this in class, it's going to be a video demo. And as it's on fire, we're going to cover it with a container so it's a closed system and put it next to BTB. So right here in this experimental sketch, I want you to pause the video and sketch this this image. Right here in your evaporating dish is the alcohol ethanol, and here is blue BTB. Look at the molecular structure of ethanol. Okay, you have carbon-carbon, carbon-hydrogen bonds. You also have carbon-oxygen bonds as well. But you also have some really high energy bonds here, carbon-carbon, carbon-hydrogen. Okay, when we put the ethanol on fire, we're going to break these bonds and release light and heat energy into the chamber through fire. And we're also going to break CO2 off of this molecule, hopefully causing this BTB to turn yellow. Okay, so this should now be in your experimental sketch. If it's not, please press pause. Right now, what we're going to do is we are going to watch the first couple minutes of the introduction video for this and fill out the prediction section as it rolls.
All right, let's talk about ethanol.
Ethanol. It's also known as ethyl alcohol. Ethanol is an organic material, and organic materials are made out of molecules that include carbon-carbon or carbon-hydrogen bonds. Ethanol is very flammable, but why does it burn?
We're going to investigate what happens to ethanol when it burns. Here's what we're working with. A scale that's accurate to 0.01 grams, BTB, a clear container to put over the burning ethanol, and finally, we've got ethanol to burn in a glass petri dish.
BTB doesn't stand for bad to the bone? See? I drew a little mullet on the BTB.
Terrell, what are you doing?
Sorry. BTB is bromothymol blue. BTB changes color when carbon dioxide is added, like when you blow bubbles into it.
We can use BTB to see if carbon dioxide concentrations increase in the air.
Okay, first let's make some predictions.
The predictions should be based on our answers to the three questions. The movement question.
Where are atoms moving?
The carbon question.
What is happening to the carbon atoms?
And the energy question.
What changes in energy are taking place?
So, we can use the scale to detect any mass changes. If we make some accurate predictions about changes in mass, that'll help us answer the movement question.
Because if there's a mass change, then that means atoms are going from one place to another. So, what do we think will happen after we light the ethanol? What will gain mass? What will lose mass?
Changes in BTB can help us answer the carbon question.
After 20 minutes, what kind of color changes should we expect to find in the BTB? And what would the color change tell us about what is happening to carbon atoms?
And finally, make a prediction that relates to the energy question. What forms of energy are involved? How is energy changing from one form to another?
I'm sure you have a lot of other burning questions.
Oi. Let's pause the video now as you discuss the following questions.
So don't discuss these three questions, just simply make a brief statement about what's going to happen to the mass of both the evaporating dish with the ethanol and the BTB, what's going to happen to the carbon that was in ethanol, and how our energy form is going to change in this reaction. Okay? I'm going to go back to the video, and as it plays, I want you to fill out the results data table. So the time you can leave blank. If you want to fill it in, you could say 0 minutes, and the final is 20 minutes, because it will sit for 20 minutes, just like our experiment did. It will tell you the average initial mass and the average final mass, I believe, at the end with the whole class data. And then right here for the time, it's also 0 minutes and 20 minutes, but what's most significant is the color. So I'm going to go back to the video.
What changes in mass will you observe? What changes in the BTB will you observe? And why? And how is this related to the movement question, the carbon question, and the energy question?
And we're back. Now let's investigate.
First, we add ethanol to the petri dish and put it on the digital scale. We're starting with 67.8 grams of ethanol.
Then we fill a petri dish with fresh, new, blue BTB right next to the ethanol.
Now we ignite the ethanol with the lighter, and then cover both petri dishes. The flame goes out pretty quickly.
After about 20 minutes, we can check for mass changes and color changes inside the container. Let's speed this up a bit.
You can see that after 20 minutes, our BTB is pretty yellow.
Now we'll measure the mass of the ethanol that's still left in the petri dish, and its mass has gone down to 66.8 grams.
We had some mass changes, and you can compare them to the mass changes from another class.
How do your results compare with those on the chart? Is there a pattern? Pause the video and discuss.
So I take that back. On your data table, it looks like they have different setups, not averageable, because it looks like they use different containers because the numbers are so different. So just use for the initial 67.8 and for the final mass 66.8.
So let's review. The mass of the ethanol went down, so atoms must be moving out of the ethanol and into the air. And this has to do with the movement question.
And the BTB turned yellow, so that means there was an increase in carbon dioxide concentration in the air.
Where did the carbon dioxide come from? Carbon dioxide molecules could be created in the flame, but the carbon atoms must have come from somewhere.
And finally, let's talk about energy.
What energy indicators did we see?
We had heat, light, and motion, all in the flame. And here's something else to think about. Where did the energy in the flame come from?
So now we're all fired up about carbon. This investigation was so hot. Hopefully we've sparked something new.
We'll see you next time.
All right, so now what we need to do is go to the completed data table and switch over now to page 26, okay? What I want you to do is do a rate graph. I want you to show how the mass of the Petri dish with ethanol changed over time. Okay. Chemical formula for the reaction, you can skip this. And then just briefly, not in complete sentences, write the evidence for the matter change. Movement, matter change, and energy change. Also, what might actually be more helpful here in terms of prepping for the test tomorrow is if you did a rate calculation for change in the mass of the Petri dish. Okay, so recap what you're doing. You finished the predictions. You have the results after the video. You are doing a rate graph for the ethanol, how it changed over time. And then you're doing a rate calculation for the change of mass of the Petri dish. And then going over briefly, bullet points are fine, the evidence is for both. When you are done with this, the last thing for class that I want you to do is go to Haiku. And it says right here, Wednesday's test review. Click on this Pear Deck and go through the different questions and we will review the answers tomorrow.